Imagine you built a city, not a small one, a real city with roads and ports and buildings that took generations to construct. You had agriculture, trade networks, maybe something that functioned like writing. Your people understood astronomy, or at least enough of it to navigate and plant crops by the stars. And then, over a few centuries, it all came apart. Climate shifted. The water rose, the soil dried out. People scattered, the buildings crumbled, and 10,000 years later nobody on Earth had any idea you had ever existed. That's not a fantasy premise. That's actually a serious question that scientists, archaeologists and geologists are increasingly willing to sit with. Not because they've found proof of a lost advanced civilization, but because they started to understand just how efficient the Earth is at erasing things. And when you understand that, the real question stops being, could something like that have existed, and starts being, how would we ever know if it had? That's what tonight is about. We're going to move carefully here. There's a real difference between genuine curiosity about what the deep past might be hiding and the kind of breathless certainty you find in certain corners of the internet where every underwater rock formation is proof of an ancient empire. We're not doing that. What we are going to do is look honestly at what we know about how civilizations disappear, what survives and what doesn't, why the archaeological record is far more incomplete than most people assume, and what it would actually take for something significant to vanish from history without leaving a fingerprint we could recognize. And along the way you're going to realize that the world has some remarkably efficient tools for forgetting things. Time, obviously, but also water, specifically the fact that sea levels have risen by hundreds of feet since the last ice age, putting enormous stretches of ancient coastline exactly where early complex societies would have settled, permanently underwater. Erosion. Plate tectonics. The simple fact that most materials humans use to build things, wood, fabric, mud brick, even certain metals, don't last. And then there's us. Humans have been quarrying old ruins for building materials for thousands of years. We have built new cities on top of old ones so many times that the concept has its own name. We have burned libraries, melted statues, paved over sites we didn't recognize as significant. We are, when you add it all up, remarkably good at erasing our own past. So when someone asks whether an advanced society could have existed before recorded history and left almost no trace, the honest answer isn't a confident no. The honest answer is something more uncomfortable. It's, we should think carefully about what traces would actually survive, and then ask whether we've been looking in the right places. That question is going to take us through geology, oceanography, climate science, archaeology, and a few genuinely strange corners of the historical record where myths and oral traditions preserve fragments of things that might be older than we assume. We're going to look at civilizations that actually did collapse and almost disappear, like the Bronze Age cultures that vanished so completely that later Greeks thought their ruins had been built by giants. And we're going to look at what any earlier complex society would need to leave behind for us to find it, and whether those things could plausibly survive tens of thousands of years of Earth doing what Earth does. This is the kind of story that works well late at night, when the day is quiet and your mind is ready to drift into something large and slow and slightly unsettling in the best way. If you're already in bed, already letting your eyes close, that's exactly why I make these. Subscribe if you haven't, and drop a comment telling me where you're listening from and what time it is. There's something I genuinely love about those comments. It's Sydney at midnight and Berlin over breakfast, and somewhere in the American Midwest at 2 a.m, all at once, all tuned into the same quiet mystery. And if you want to listen without any interruptions at all, no ads, no music, just the voice and the story, you can follow the channel on Spotify. The link is in the description. It's free, it helps keep this going, and honestly, it's a pretty good way to listen if you're trying to actually fall asleep. Alright, let's go back, not to a specific date, not to a confirmed civilization, but to a question that the Earth itself might be quietly answering if we learn how to read it. What would we actually miss, and why? Before we can ask whether something was erased, we have to agree on what it was. And that turns out to be harder than it sounds, because when people say advanced civilization, they usually mean something like us. Cities, electricity, global trade, written language, the internet. But that's setting the bar in a very specific place, and it's a place defined almost entirely by what we happen to have built in the last few thousand years. If we're asking whether something genuinely complex could have existed before recorded history and then disappeared, we need to think more carefully about what complexity actually looks like and which parts of it leave marks. So let's build a definition from the ground up. Technology is the obvious starting point. Stone tools are technology, and we've had those for about 3 million years. But there's an enormous distance between a hand axe and a fired clay pot, and another enormous distance between a fired clay pot and a kiln capable of reaching temperatures high enough to smelt copper. Each of those steps represents not just a different tool, but a different relationship between humans and materials, a different level of understanding about how the physical world behaves under controlled conditions. By the time you're smelting metal, you're doing something that requires sustained high heat, knowledge of ore deposits, transportation of raw materials, and a social system organized enough to support specialists who don't grow their own food. That last part matters more than the metal itself. Because advanced doesn't just mean good tools, it means organized complexity. A society where not everyone is doing the same job, where some people farm, and some people build, and some people trade, and some people manage information. Division of labour is actually one of the clearest signatures of a society that's crossed a threshold from survival to something more structured. It's also, interestingly, one of the things that's hardest to find in the fossil record, because labour doesn't leave bones behind. Engineering is more visible, at least in principle. If a society builds anything large and durable, roads, walls, irrigation canals, harbours, terraced hillsides, those structures can survive for a very long time under the right conditions. The problem is that the right conditions are rarer than you'd think, and we'll get into exactly why in later sections. But for now, the important point is that engineering scale construction implies things we care about: planning across time, collective labour, some system of authority or cooperation that can direct hundreds or thousands of people toward a shared goal over years or decades. A single person doesn't build a canal. A band of 30 hunter-gatherers doesn't build a harbour. Writing is where most people draw the line. We call it the beginning of history for a reason. Writing lets a society store information outside of human memory, pass it between strangers, and accumulate knowledge across generations in a way that oral tradition struggles to match at scale. But here's the thing worth sitting with. Writing is also almost comically fragile. It exists on clay, papyrus, bark, skin, stone. Of those materials, stone survives well, clay survives under certain conditions, and everything else tends to disappear within centuries, unless someone is actively protecting it. The Library of Alexandria wasn't destroyed once. It declined over hundreds of years, with various fires and neglect and political disruptions, and most of what was lost probably looked unremarkable, right up until it was gone. If a literate society collapses completely, its writing doesn't automatically survive. It has to be copied, preserved, discovered, and decoded. We've found scripts we still can't read. Linear A, the Proto-Elamite script, the Indus Valley script. Someone wrote in those languages for centuries, and we have no idea what they said. So writing is a signature of complexity, but its absence isn't evidence that complexity didn't exist. That's a crucial distinction, and one that archaeologists are careful about. What does survive more reliably are what you might call ecological signatures. Evidence that a human population was interacting with its environment in a systematic, large-scale way. Domesticated plant and animal species, When you domesticate wheat, you change it genetically, and those genetic changes persist in wild descendants for thousands of years. You also change the landscape. Clearing forest for agriculture creates a particular kind of sediment record. Pollen sequences in ancient lake beds show shifts in vegetation that correlate precisely with human activity. Grazing animals compact soil differently than wild ones. Irrigation leaves chemical traces in sediment layers. These are not obvious things to find, but they're findable. And they tell you that someone was doing something organized and large-scale, even when they left no buildings and no writing behind. Trade networks are another signature that doesn't require walls or words. When obsidian from a specific volcanic source in Anatolia shows up at sites in Egypt, or shells from the Mediterranean show up in settlements 1,000 kilometers inland, that's evidence of a system. Someone organized the movement of those objects. Someone understood the value of what they were trading. Someone maintained relationships across distance over generations. And the objects themselves are durable. Stone doesn't rot. Shell mostly doesn't either. When archaeologists find materials that couldn't have arrived at a site by accident, they're seeing the echo of a network, even if the people who built that network left nothing else. Pollution is newer to this list, but increasingly useful. Certain human activities leave chemical signals in ice cores, lake sediments, and peat bogs. Smelting metals releases lead and copper particulates. Burning large areas of forest for agriculture changes carbon ratios. These signals can persist for tens of thousands of years in the right depositional environments. We've actually detected what appears to be early metallurgical pollution in Greenland ice cores, going back well before what we consider the start of the Bronze Age. That data is still being interpreted, but it illustrates the point. Even industrial activity, if it happened, might leave traces we're only now learning how to read. This brings us to a concept that archaeologists call taphonomy. It's the study of what happens to things after they die or after they're abandoned. How organic material decays, how sediment buries and preserves, how objects move through the environment over time. Taphonomy is essentially the science of survival bias, of understanding not just what we find, but why we find those things and not others. And when you take it seriously, it changes how you think about the archaeological record. The record is not a neutral sample of everything that existed. It's a heavily filtered collection of what happened to survive the specific conditions of specific places over specific periods of time. Bone survives better than wood. Stone survives better than bone. Dry environments preserve better than wet ones. High elevations preserve better than coastlines, which, as we'll get into, are now underwater. Everything we found is everything that made it through a very long, very arbitrary obstacle course. Everything we haven't found might have existed and simply didn't survive, or might never have existed at all. Taphonomy can sometimes help you distinguish between those two possibilities, and sometimes it genuinely can't. This is where the absence of evidence argument gets complicated. People sometimes say absence of evidence is not evidence of absence, and that's technically true. But it's not a blank check. If you're looking for evidence of something in exactly the places and layers where it should appear if it existed, and you find nothing, that absence starts to mean something. It's not proof, but it shifts the probability. What taphonomy tells us is that there are also situations where the places and layers that would contain the evidence simply don't exist anymore or have never been systematically examined. In those cases, absence really does say very little. For a civilization that might have existed 10, 15, 20,000 years ago during and before the last ice age, we are genuinely in that second category in many respects. The coastlines where complex societies would most likely have settled are under hundreds of feet of ocean. The sediment layers that would contain their debris have been scoured by ice sheets, buried by river systems, or simply never excavated because we didn't think to look there. The organic materials they would have used for almost everything are gone. What would remain are the hardest, most durable signals. The geological ones, the chemical ones, the genetic ones. The deep structural marks left in the landscape by people who were doing things at scale. Whether those marks exist, and whether we've learned to recognize them for what they are, is the actual question underneath all of this. And to understand why finding them would be so difficult, you first have to understand just how thorough the Earth is when it decides to bury something. The planet does not just sit there politely holding on to whatever we leave on its surface. It is constantly, relentlessly grinding, dissolving, and carrying things away. From our perspective, landscapes feel permanent because human lives are short. A village might last for centuries, a city for millennia. The mountain on the horizon looks eternal because your grandparents saw the same outline, and their grandparents did too. But from the perspective of geology, everything is in motion. Rock is temporary, coastlines are a phase, a building, even a city, is just a brief experiment in how long a stack of materials can resist water, wind, temperature, and chemistry. Start with the simplest enemy, rain. Every drop that falls on a wall, a road, a temple does a tiny amount of work. It seeps into cracks, dissolves minerals, loosens grains of sand. Multiply that by billions of drops over thousands of years, and you have a solvent that can literally eat mountains. Flowing water is worse. A small stream can carry away silt and sand, undercut foundations, widen cracks in masonry. In flood, that same stream becomes a demolition machine, lifting whole blocks, ripping out bridges, scouring away anything not anchored deeply enough into bedrock. Wind is less dramatic in the moment, but just as effective given time. Dust and sand picked up by wind turn into a natural sandblaster. It rounds carved edges, erases inscriptions, softens sharp corners into featureless lumps. Ancient stone statues in deserts lose their faces, not because someone vandalized them, but because they spent a few thousand years being lightly sandpapered from every direction. Paint goes first. Fine carving goes next. Eventually you're left with anonymous boulders, still technically there, but no longer obviously artificial. Then there is the freeze-thaw cycle, one of the most efficient silent destroyers on Earth. Water seeps into tiny pores and cracks in stone or concrete. When the temperature drops below freezing, that water expands as it turns to ice, forcing the cracks slightly wider. When it thaws, more water can enter, freeze again, expand again. Repeat this process for a few hundred winters, and you can split a boulder, peel apart a wall, or shatter a staircase into rubble. In regions with strong seasonal swings, even very durable materials eventually fracture, crumble, and become part of the surrounding soil. Rivers take whatever these processes break loose and move it. They eat at their banks, shift their channels, and meander across floodplains like slow, restless animals. Over time, a river can migrate kilometers away from where it used to be, abandoning old beds, cutting into new ground, and depositing layer after layer of silt and sand over whatever happened to be in its path. A town built near a river might flood repeatedly for a few centuries, then be buried entirely by its own flood deposits, and finally sit beneath farmland or a new city, with no visible trace left at the surface. All of this mechanical shredding is only half the story. The other half is chemical. Soil is not just ground-up rock. It is a living mix of water, oxygen, carbon dioxide, organic acids produced by plants and microorganisms, and countless tiny scavengers. Anything organic that ends up in that environment, wood, cloth, leather, bone, enters into a race against decomposition. In most climates, the microbes and fungi win quickly. Bone seems tough, but it is mostly a porous composite of mineral and collagen, in mildly acidic soil that mineral dissolves. The collagen is eaten by bacteria. Given a few thousand years, even a mass grave can melt away until only faint discolorations or differences in soil texture mark where bodies once lay. Wood fares even worse. exposed wood rots in decades. Buried wood, unless sealed in waterlogged oxygen-poor conditions, is consumed by fungi and bacteria, leaving a ghost of darkened soil, sometimes an impression, but no structure. Textiles are some of the most fragile artifacts we make. Cotton, linen, wool, silk, these are all organic fibres. Without extremely dry, frozen or anoxic conditions, they vanish within centuries. We know this because we almost never find them older than that, unless they happen to have been trapped in peat bogs, sealed in tombs, or desiccated in deserts. Imagine a civilization that expressed much of its complexity through cloth, rope, woven mats, and paper-like materials. Most of what defined it at the everyday level would be gone long before anyone came digging. Even many metals do not behave the way our intuitions tell us. Iron rusts. Exposed to oxygen and water, it forms flaky iron oxides that eventually crumble, taking the original shape with them. Thin iron objects, tools, nails, plates, can corrode to nothing over a few thousand years in aggressive soils. Copper and bronze are more stable, but they still corrode, forming thick green patinas or crusts that obscure detail and over longer stretches eat inward from the surface. Under the right conditions, a bronze statue might survive for tens of thousands of years. Under the wrong conditions, it turns into a misshapen lump of corrosion products that could easily be mistaken for a natural mineral deposit. Meanwhile, the land itself is shifting under whatever remains. Dunes march across deserts, grain by grain. A buried building can be uncovered by one migrating dune, and then swallowed by another. Coastlines erode, cliffs retreat metre by metre, dropping whatever stood on their edges into the sea. Deltas grow outward as rivers deliver sediment. Salt marshes expand and contract. Barrier islands form, break, and reform somewhere else. Badlands develop where soft sedimentary rock is exposed to intense erosion, carving strange, steep landscapes out of what were once gentle plains. Anything unlucky enough to sit in these zones of rapid change is either dismantled, transported, or deeply buried. This constant migration means that preservation is profoundly uneven. Some environments are vicious. Tropical rainforests, for example, are almost perfect machines for destroying evidence. High temperatures, abundant water, acidic soils, and dense biological activity combine to break down organic matter with astonishing speed. Fallen trees can disappear completely in a handful of years. Bones dissolve quickly, metals corrode aggressively. Erosion is fast, and thick vegetation overwrites human disturbance within decades. A technologically complex society could farm, build in wood, work metal, and leave behind almost nothing recognizable after 10,000 years in such a setting. Temperate zones are gentler, but still not friendly over long timescales. Seasons mean cycles of wetting and drying, freezing and thawing. Forests reclaim abandoned fields. Roots break apart foundations. Rivers continue to rearrange their floodplains. Artifacts and structures do survive here, but patchily, and their survival often depends on accidents. Burial by a landslide, entombment beneath volcanic ash, sinking into a bog, or being sealed under urban rebuilds. Deserts and cold, high-altitude regions are where time sometimes stalls. In very dry air, decay slows dramatically. Organic materials that would normally vanish can persist. Mummies in Egyptian tombs, wooden beams in Andean ruins, textiles in desert graves. In permafrost, where ground stays frozen year-round, preservation can be extraordinary. We've recovered Ice Age animals with hair and stomach contents intact, and human garments thousands of years old. But these are rare environmental pockets. They preserve what happens to fall into them. They are not evenly sampling the whole surface of past human activity. This brings us back to stone. Stone is what we mostly find, not because it is what people mostly used, but because it is what mostly lasts. A stone temple can endure when wooden houses around it are gone. A foundation of cut blocks may remain when the mud brick walls it once supported have turned back into undifferentiated earth. But even when stone survives, its context often does not. The paint, the plaster, the carvings, the roofs, the wooden doors and furniture, the fabric canopies, the surrounding gardens and streets, all of the organic and semi-organic parts that told you how the place was actually used, vanish first. So you end up with scattered fragments, a line of worn blocks on a hillside, a few stone tools in a ploughed field, a discoloured layer in a riverbank. They whisper that someone was there, that something was built, that work was done. But the richer details, the scale of population, the intricacy of their crafts, the complexity of their records, erode faster than the raw materials that hinted at them. If we're wondering what kinds of civilizations could be missing from the deep past, this is the filter they would have had to pass through. Not just the violence of singular catastrophes, but the quiet, patient violence of weather and time. And this surface shredding is only one stage. Underneath it, a slower, deeper process is at work, rearranging the very crust those fragments sit in, turning continents into recycling systems that can erase entire chapters of geological history. That recycling system is plate tectonics. If erosion is the planet's paper shredder, plate tectonics is the industrial furnace in the basement, quietly feeding on the shredded pieces and turning them back into raw material. The outer shell of the Earth is not a single solid piece. It is broken into great plates of rigid rock, floating very slowly on the hotter, softer mantle beneath. Some plates carry continents, some carry ocean floors. They slide past each other, collide, pull apart. To us, they are motionless. To geology, they are restless rafts, constantly rearranging the face of the world. Now imagine that, in some deep past, an advanced maritime society hugged a long chain of coasts and shallow seas. Harbours, breakwaters, ports, maybe even cities built out on platforms and islands. Where would most of their remains be today? On the ocean floor. And that is the most temporary real estate on Earth. Unlike the ancient cratons that make up the cores of continents, oceanic crust is young. New seafloor is born at mid-ocean ridges, where molten rock wells up and solidifies. Then, as more magma rises, the older crust is pushed aside, sliding away from the ridge like a slow conveyor belt. But conveyor belts go somewhere. For most oceanic crust, that destination is a subduction zone. At subduction zones, one plate is forced beneath another and sinks back into the mantle. Ocean floor, with all its sediments, all its fossils, all its potential traces of coastlines and harbours and shipwrecks, is dragged downward into a realm of increasing heat and pressure. Given enough depth, it stops being crust in any recognisable sense, and becomes part of the flowing, convecting interior of the planet. On average, oceanic crust is only about 100 to 200 million years old. That sounds like a lot, until you remember that Earth is 4.5 billion years old. There is more time missing from the seafloor record than present in it. Anything built on the deep ocean before the age of the dinosaurs would not just be buried. It would be gone in a literal sense, the rock itself recycled, the atoms of any structures mixed into new magma. Even coastal margins are not safe. Sediments eroded from land pile-up along continental slopes and deep ocean trenches. As plates converge, these piles are scraped, folded, and partly dragged down with the subducting slab. Imagine a great coastal city being slowly buried by its own eroded hinterland. Then the entire margin tilted, folded, pushed downward. After tens of millions of years, its stones would not simply lie deeper. They would be transformed or melted, their original shapes and arrangements erased at the grain level. The Earth is not just covering its tracks, it is reusing the paper. Where plates collide but neither is easily subducted, something else happens, uplift and mountain building. When two buoyant continental blocks meet, they can't easily dive under one another. Instead, they crumple. Layers of rock that were once horizontal are folded, faulted, stacked. A former coastal plain might be shoved tens of kilometers inland and several kilometers up into the heart of a rising mountain range. This sounds like good news for preservation. Higher means drier, right? Maybe more likely to survive. Initially, yes, rocks can be insulated from some surface processes by burial and uplift. But mountain belts are also zones of extreme deformation. Those neat geological layers you see in textbook diagrams, flat bands of sandstones, shales, limestones, get twisted into tight folds, sliced by faults, duplicated and stacked like a shuffled deck. Structures buried within them are stretched, sheared, and dislocated. Picture a city plan drawn on a sheet of rubber. Now crumple the rubber, pull parts of it sideways, fold it back on itself, and finally shred the outer margins with scissors. Somewhere inside, a few distorted pieces of the street grid might technically still exist, but good luck recognizing them as a city, or even as straight lines. That is what colliding continents do to the rocks that carry their older stories. Deeper still, as buried crust is pushed down or over-thickened, the pressure and temperature climb. Here we enter the realm of metamorphism. This is not melting, at least not yet, but it is close. Under metamorphic conditions, minerals rearrange themselves. New minerals grow. Old ones dissolve. Grains rotate and recrystallize. Sedimentary rocks like sandstone or limestone can be transformed into hard quartzite or marble. Shales can become slate, then schist, then gneiss with striking banded patterns. Each step in that progression means more of the original texture, more of the original content has been overwritten. Fossils, if there were any, are among the first casualties. Delicate shells, bone fragments, impressions in mud, they deform, smear, or recrystallize into featureless patches. After a certain point, even a trained geologist can no longer tell what the protolith, the original rock, used to be. And if the rock no longer remembers it was once a shallow seabed, it certainly no longer remembers that it once contained, say, a harbour wall or a buried foundation. This is one of the quietest but most thorough erasers on Earth. Metamorphism doesn't have to pulverize anything to remove its story. It simply reorders the atoms until the narrative stored in their shapes, pores and arrangements is gone. When rocks that have been through this journey are later uplifted and exposed again, they often form the rugged cores of mountain ranges. Hikers admire the beautiful banded gneisses and gleaming marbles. But from the standpoint of reconstructing deep history, these rocks are like reprinted paper. The old text has been replaced by a new pattern. Now step back and look at the planet as a whole. After billions of years of this cycling, spreading, subduction, uplift, erosion, metamorphism, how much of Earth's original surface is left? Very little. Truly ancient surfaces, where the top few meters of rock have remained more or less in place for hundreds of millions or billions of years, are rare. They tend to be found on the oldest, most stable parts of continents, shield areas in places like Canada, Greenland, parts of Africa and Australia. Even there they have been scoured by ice, weathered by rain, veiled by soil. Compared to the enormous span of geological time, most of what we walk on is relatively recent rearrangement. Rocks themselves may be old, but the surfaces that carry our cities, our roads, our traces, are young and constantly refreshed. Imagine trying to study the entire history of a library where the floors, shelves and walls are ripped out and rebuilt every few 100,000 years. A few books might be left from older phases, accidentally walled up in a corner or buried under a stair. Most will be gone without a trace. This is where it helps to compare Earth with worlds that do not recycle themselves so aggressively. Look at the Moon. Its surface is ancient. There is no wind, no rain, no plate tectonics. Impacts pockmarked it in the early solar system, and those craters are still there. You can see scars billions of years old with a backyard telescope. If someone had built a city on the moon a billion years ago and it had been made of stone, large-scale outlines might still exist today, softened by micrometeorite dust but not dragged into the mantle. Mars too has areas where the crust has sat in place for extremely long periods. Its volcanoes and canyons preserve features hundreds of millions of years old. There is erosion, dust storms, seasonal frosts, ancient river channels, but no global system that routinely swallows and remakes the crust. Sediments stack, craters accumulate. The old is more likely to stay on top of the new, rather than being thrust underneath it. Earth is the opposite. Our world keeps clearing its canvas. This constant clearing is not just a geophysical curiosity. It sets hard limits on how far back we can realistically expect to see the fine details of any surface civilization, especially one that relied heavily on coasts and seaways. It also points us toward the places where traces are most likely to be hidden, not out in the deep ocean, where crust is young and doomed, but where water and land interact in more complicated ways. Those liminal zones, the floodplains, the shifting deltas, the drowned shelves at the edges of continents, are where we turn next. Follow a river from its source to its mouth, and you are really following a conveyor belt of ground-up continents. High in the mountains, water is fast, thin, and wild. It cuts into rock, plucks boulders from cliffs, grinds them into gravel, sand, and silt. Every flood, every spring melt, every storm carries a fresh dose of pulverized landscape downstream. By the time that water reaches the lowlands, it has slowed, spread, and thickened. The raging torrent has become a broad, looping river, wandering across a flat plain of its own making. All that material it stole from the uplands has to go somewhere. Here is where it lets go. This is a floodplain. A wide, low-lying belt of land built, year after year, flood after flood. From the sediments a river drops when it spills over its banks. It looks stable at human timescales. Dark soil, level fields, gentle slopes. In reality, it is one of the most active surfaces on Earth. And humans love it. Floodplains are where some of the richest soils are found. Regular doses of silt and clay keep them fertile without fertilizer. Rivers bring water, fish, transport. They knit together far-flung regions into trade routes. If you want to build an early city, especially before modern pumps and long-distance plumbing, this is where you go. Now combine that with what a floodplain actually does over centuries and millennia. Every time a river overflows, it lays down a thin layer of sediment on its floodplain. A few millimeters, a centimeter or two in a big event. Most years, people barely notice. Maybe you sweep some extra mud off the doorstep. Maybe you rebuild a collapsed wall. But that is the view from one lifetime. Stack lifetimes and the picture changes. A century of floods can lay down a few tens of centimeters of new material. 1,000 years can pile up meters, 10,000 years can build tens of meters. Under the right conditions, a flat green field you see today may actually be the top of a huge layered cake, flood deposit on flood deposit, each one a thin sheet of river-borne dust, burying whatever existed before it. If a town or a village or a city stands on that plain long enough, it starts to participate in this process. Houses burn, roofs collapse, walls crumble. People level the rubble, spread fresh fill, build new structures on top of the old foundations. Floods bring in more silt, wind blows in more dust. Trash pits, broken pottery, abandoned streets all get covered, flattened, reused. In places like ancient Mesopotamia, this cycle played out for millennia. The result is what archaeologists call a tell, an artificial hill created by the repeated burial and rebuilding of settlements on the same spot. From a distance, a tell can look like a natural rise in an otherwise flat valley. Up close, when you cut into it, You find stacked layers of human life, one on top of another, separated by thin bands of river mud and wind-blown dust. To the people who lived in those cities, the past was literally underfoot. A new temple might be built on the levelled ruins of an older one. A house might dig its cellar into someone else's courtyard from centuries before. Over time, the whole complex slowly rose above the surrounding plain, riding on a pedestal of its own debris. Now imagine standing in the same place after the city is finally abandoned. Without constant maintenance, walls slump, roofs collapse. Mud brick dissolves in rain. One or two big floods later, and the last visible ruins are eroded into shapeless mounds. The river keeps delivering silt. Farmers arrive, attracted by the same fertile soil that drew the first settlers. They plough the surface, smoothing those mounds a little more each year. Give it enough time, and that once bustling city becomes an unremarkable low hill in an endless expanse of fields. No soaring ruins, no jagged walls, just a subtle swelling of the ground, maybe a slightly different colour to the soil after the plough passes. That is, if the river stays where it is. Floodplains are not just about vertical stacking. They are about horizontal wandering. Big rivers do not like to stay in neat, fixed channels. Over centuries they swing back and forth across their plains in great looping bends. They cut into one bank, deposit on the other, abandon old meanders, carve new ones. Whole channels can shift kilometres sideways. Deltas can leap to new positions along a coastline after major floods or tectonic jolts. From above, over long spans of time, a mature river doesn't trace one line, it scribbles all over its floodplain. If a city happens to sit near an active channel, that scribble can be catastrophic. Sometimes a flood undercuts the outer wall of a town, collapses it, and eats its way inward, bite by bite over a few seasons. Sometimes an extreme event, an ice jam, a monsoon anomaly, a breached levee diverts the main current down a new path that runs straight through the built-up area. Streets, houses, temples, marketplaces, all can be scoured away. Their stones tumbled downstream and buried in sandbars and levees, far from their original positions. What survives in place may be little more than deeply buried foundations, now sealed under meters of river gravel and silt. From the surface, with no exposed stone, the old city's exact footprint can vanish. Even when a channel doesn't destroy a settlement outright, its gradual migration can mislead later observers. A tell that once sat right on the riverbank might end up stranded kilometres away as the river swings off in another direction. To a modern eye, the mound may look oddly placed, far from water on no obvious trade route. Without understanding the river's older paths, it is easy to miss the logic of why it was there at all. Then add agriculture to the picture. For as long as there have been farmers, humans have been reshaping floodplains in ways that confuse the record even further. Irrigation canals cut across natural drainage lines. Dikes and embankments trap sediment in some places and divert it from others. Fields are levelled and re-levelled. Low spots are filled. High spots are scraped down over thousands of years. This creates a patchwork of artificial micro-relief draped over the original floodplain. To an archaeologist, this is both a blessing and a curse. Human earthworks can preserve traces of older features by burying them, but they can also mix layers, move soil from one place to another, and blur the clean chronological stacking that geologists like to see. Picture a farmer in some early irrigation culture digging a new canal. He cuts a trench through what he thinks is ordinary subsoil and tosses that earth aside to build the canal bank. In that spoil are fragments of brick, charcoal, pottery from an older settlement he never knew existed. Buried a metre down, the canal runs for a few generations, then silts up. Later farmers level it, spreading that mixed soil across their fields. Centuries later, someone else comes along with a plough or a bulldozer and reorganizes the top meter yet again. By the time we arrive with satellite images, ground-penetrating radar, and careful trowels, the surface of a floodplain is a palimpsest. Written on, scraped, written over, smeared, written over again. Some deep, intact layers may still be there, but finding them and interpreting them can be slow, painstaking work. And the scale is overwhelming. Major river basins like those of the Nile, the Tigris and Euphrates, the Indus, the Yellow River, the Mississippi, cover hundreds of thousands to millions of square kilometers of floodplain and delta. Much of that land is under active cultivation or buried under modern cities and infrastructure. Only small patches have been probed in detail. When archaeologists test a floodplain, they usually work in narrow slices. A trench here, a core there, a rescue excavation before a new dam or highway. From those slices they infer broader patterns, but there is no practical way to peel back the entire plain and look at it layer by layer. It would be like trying to reconstruct the history of a whole library by sampling a few cores drilled through the floors. This means we are almost certainly missing things, not only individual houses or villages, but possibly whole phases of intensive occupation in areas that now look like undisturbed farmland. Early experiments in irrigation, proto-urban centres that rose, fell, and were entombed long before later waves of settlement. Sometimes we get a hint. A farmer's plough turns up a carved stone where no ruins are mapped. A drought drops a river enough to reveal foundations in its banks. A flood cuts a new channel, and suddenly, in the raw vertical face of a fresh meander, you can see brickwork and charcoal in a layer that no one knew was there. Those are accidents, moments when the river briefly reveals what it has been hiding. Most of the time it does the opposite. It hides and keeps on hiding. If you were looking for the traces of a very early, very fragile experiment in complexity, a network of riverine towns may be linked by boats and canals. Floodplains and deltas are the natural places to look. They are where water, soil, and human need converge. They are also places that specialize in making whole worlds vanish under a quiet, steady rain of silt. And if rivers can bury cities on land, what happens when the sea joins them, when coastlines drown, deltas sink, and the water itself rises over the floodplain? To trace that part of the erasure, we have to follow the rivers one step farther, out into the drowned edges of the continents. Follow those rivers all the way out past their last meanders, past their shifting levees and braided channels, and you come to the place where their stories used to end. Not at today's shore, but far out, on ground that is now under tens of meters of water. For most of the last few 100,000 years, sea level has not been where it is now. It has been lower, sometimes a little lower, sometimes shockingly lower. During the last ice age, at its peak around 20,000 years ago, so much water was locked up in continental ice sheets that the global ocean dropped by more than 100 meters. Imagine every coastline you know pulled outward, exposing vast shelves of land that are now hidden under water. The North Sea basin between Britain and mainland Europe, dry grassland and marsh, crisscrossed by rivers, home to herds of animals and, as we now know, humans. The broad Persian Gulf, mostly a wide, low-lying valley with a large river system flowing through it, fed by the Tigris, Euphrates and other streams. The Sunda Shelf, around what is now Indonesia, a single huge landmass connecting many of today's islands into one continuous tropical subcontinent. All along the edges of the continents, what we think of as the sea was once land, hills, plains, lagoons, estuaries, deltas. The true shoreline lay far beyond today's beaches. Then the Ice Age ended, not all at once, not overnight, but in pulses. Glaciers melted, ice sheets thinned, retreated, collapsed. The oceans began to rise. Over roughly 10,000 years, global sea level climbed those 100+ meters sometimes gently, sometimes in surges when big ice reservoirs suddenly gave way. To someone living through it, the change might not have looked dramatic on a yearly basis. A few centimetres here, a few there, a high tide creeping a little farther up the beach than last year, a low-lying meadow turning into a salty marsh, a fishing camp that had to be moved inland once or twice in a lifetime. But stack lifetimes, and the picture changes again. Whole river valleys at the coast flooded, turning into estuaries and then into bays. Deltas, those great flat fans of fertile soil at river mouths, were drowned from the seaward side. Their outer edges bitten away, their inner reaches turned to wetlands and then open water. Barrier islands migrated, broke, reformed. Beaches marched landward, step by slow step. If you had built anything on that exposed shelf, villages, fields, shrines, harbours, fish traps, canals, you watched the ocean come to meet you. And coasts are exactly where humans like to build. They concentrate everything early complex societies crave: fresh water from rivers and springs, access to fish and shellfish, fertile soils along estuaries and deltas, easy travel by boat along the shore and upriver, trade routes that link inland and overseas resources. A coastal settlement can act as a hinge between worlds, sea and land, river and ocean, different ecological zones, different cultural regions. Even very simple societies recognize that advantage, whether or not they think of it in those terms. All over the world, the earliest known farming cultures, trading hubs, and urban experiments hug coasts and lower river valleys. Mesopotamia at the head of the Persian Gulf, the Nile Delta, the Indus Valley meeting the Arabian Sea, the river mouths along the Chinese coast, the Eastern Mediterranean, and those are just the parts we can still see. Shift the shoreline by tens of kilometres, flood the outer deltas, drown the low shelf, and you do not just erase beaches. You erase the prime real estate, the best fishing grounds, the easiest harbours, the obvious places for early experiments that sat somewhere between village life and full-blown cities. The hard part is that the ocean is not just a gentle blanket of water. It is an active, abrasive, dissolving, rearranging force. When rising seas invade a coastal plain, they do what rivers do and more. Waves chew at cliffs, storms rip up shorelines, tides pump water in and out of sediments twice a day. Fine-grained muds settle in sheltered spots. Sands and gravels shift back and forth along the coast. Organic remains get eaten, scattered or rotted away by marine life. Stone structures can survive, but they may be toppled, buried, or broken. Wood decays, metal corrodes, fibres and textiles vanish. Even where things are preserved, they are hidden under layers of marine sediment in cold, dark water, often far from any obvious landmark. For an archaeologist working on land is already like reading a book with half the pages missing. Working underwater is like trying to read those same pages in a locked, flooded archive where you need special equipment just to crack the door. Visibility is poor. Light fades quickly with depth. Currents tug at divers. Every minute on the bottom is carefully rationed by air supply and decompression limits. Mapping a site that would take days on land can take months or years underwater. The costs are high. You need boats, trained divers, sonar, remotely operated vehicles, specialized conservation labs for any artifacts you manage to bring up. Saltwater begins to attack fragile objects the moment they are raised. Wet wood can shrink and crack if it dries too fast. Metal concretions have to be stabilized before they simply crumble. And the searchable area is vast. Continental shelves alone cover millions of square kilometers. Only tiny fractions have been systematically scanned with high-resolution sonar or explored by archaeologists. Most underwater discoveries so far have been accidental, noticed by fishermen snagging nets, or by energy companies surveying for pipelines, or by coastal engineers mapping seafloors. Even so, what little we have found is suggestive. Off the coast of India, near the Gulf of Khambat, and around the submerged ruins at Dwarka, surveys and dives have revealed stone structures, walls, and possible harbour works now under several metres of water. The dating and interpretation are debated, as they always are with difficult sites, but the basic fact is clear: people built on ground that is now seabed. In the Black Sea, where deep waters are anoxic and preservation is unusually good, researchers have found remarkably intact shipwrecks and hints of ancient shorelines far below the modern surface, reminders that the sea there invaded a formerly freshwater basin thousands of years ago. Off the British coast, sonar and core samples from the North Sea, Doggerland, have revealed buried river channels, peat layers from ancient wetlands, and scattered bone tools and artefacts. This was once a broad, habitable lowland, dotted with lakes and marshes, gradually overwhelmed as the post-glacial sea advanced. In the eastern Mediterranean, submerged Bronze Age harbours, breakwaters, and even parts of coastal towns lie just offshore, victims of both sea level rise and local subsidence. Along the Italian and Greek coasts, you can trace drowned Roman structures under a few metres of clear water. These examples are recent in geological terms, and their builders are not mysterious to us. They show something simple but important. Coasts shift, seas rise, and human constructions can vanish under the waves within the span of recorded history. Now stretch that process back beyond writing, back through the early Holocene, when sea level was still climbing, back into earlier interglacial periods, when climate warmed and seas rose again and again over landscapes that had been dry through the preceding ice age. Every interglacial would have created new coastlines, new estuaries, new deltas. Every glacial maximum would have exposed wide shelves. Human or human-like species were present through many of these cycles. They would have discovered, forgotten, and rediscovered the advantages of the shore over and over. If any early fragile coastal-focused experiment in complexity arose before the current warm period, small towns, trading communities, networks of seafaring villages, they would have had the odds stacked against their long-term visibility. First, their chosen locations would be exactly where the ocean is most eager to reclaim land as climate warms. Second, their remains would be consigned to environments that are expensive and difficult for us to explore. Third, later sea level fluctuations, storms, currents, and sedimentation would selectively erode and bury the more delicate traces. This does not mean there was a hidden industrial civilization with skyscrapers and satellites on some vanished shelf. The geological and geochemical footprints of that would be hard to miss. But it does mean that large portions of the story of early coastal life, and perhaps the earliest steps toward complex maritime-oriented societies, may lie offshore in zones we have barely sampled. From the quiet surface of the sea, looking inward toward modern cities clustered along today's coasts, it is easy to think we are seeing the whole stage of human history. In reality, we may just be looking at the latest set. Beyond the surf, under the silt and sand of the drowned margins, older acts may be entombed, their props and backdrops blurred by water and time. And even where the sea does not reach, the climate itself can alter the script. Because sometimes the water does not just rise slowly and steadily. Sometimes the entire environment flips, cold to warm, wet to dry, ice to forest in the space of a few centuries or less. To follow those jolts and what they do to any civilization unlucky enough to be in the way, we have to turn from the coasts to the ice. Ice is slow when you watch it, but in the long view ice can behave like a switch. Over the last couple of million years, Earth's climate has not been a steady, gentle curve. It has been a sawtooth, long, grinding descents into cold and shorter, relatively sharp leaps back into warmth. Glaciations grow like debts, a bit more snow each winter than melts each summer. Year after year, century after century, until ice sheets hundreds or thousands of meters thick sprawl out from the poles. Sea levels fall, deserts expand. Forests retreat into scattered refuges. Grasslands stretch across what are now temperate zones. Then, for reasons that have to do with subtle shifts in Earth's orbit and axis, plus feedbacks from ice and oceans and greenhouse gases, the system tips the other way. Warming accelerates. Glaciers thin, ice fronts pull back, meltwater floods into the seas. Each full cycle, cold build-up, warm release, takes on the order of 100,000 years in the recent part of Earth's history. Within that broad rhythm, habitable zones migrate like slow-moving belts around the planet. Where boreal forest stands today, there may have been tundra and ice. Where temperate forest once spread, there may have been open, windswept steppe. Regions that are fertile now may have been locked in permafrost. Regions that are marginal now may have been lush. To a species that lives for 70 or 80 years, this is almost invisible. To a society that lasts a few centuries, it is a creeping pressure rather than a single catastrophe. But over the course of a glacial cycle, the entire map of good places to live is redrawn. That's the slow version. Layered on top of those long swings are the jolts, abrupt climate events where the system seems to lurch from one state to another in a geological instant. Ice cores from Greenland and Antarctica record these lurches as sharp steps in the chemistry of ancient snow. Ratios of oxygen and hydrogen isotopes that track temperature. Entrapped bubbles of greenhouse gases. Layers of dust and volcanic ash. The cores are like tree rings, but for ice, year by year, sometimes season by season, for hundreds of thousands of years. When researchers first started reading them at high resolution, they found something unsettling. Temperatures in the North Atlantic region have not always drifted gently. They have at times spiked up or crashed down by several degrees in a matter of decades. Maybe less. Events like the Younger Dryas, around 12,900 years ago, when a warming world was suddenly thrown back into near-glacial cold, probably by a massive influx of fresh water into the North Atlantic, or even smaller cold snaps and warm surges, the so-called Dansgaard-Eschger events, popping in and out through the last ice age. We don't have daily weather reports from those times. We cannot say that any particular year felt like a disaster movie. But we can say that on the scale of human generations, environments changed fast enough to demand new strategies, or to punish anyone who could not adapt. Picture a community that has built its life around a rich tundra forest edge, with migratory herds passing predictably each year. Fish runs in swollen spring rivers berries and nuts from nearby woods. Then, within a few lifetimes, the winters lengthen, summers shorten, vegetation zones shift hundreds of kilometers south. Rivers freeze longer. Herd routes bend away from your valley. The plants and animals you know decline, and unfamiliar ones move in, or nothing much moves in at all. No single day destroys your society, but the background conditions that made it viable begin to unravel. Under those pressures, people move. Sometimes it is a gradual drift, families following the animals and plants that sustain them. Sometimes it is a more chaotic push and pull, as groups run into each other at ecological bottlenecks, narrow corridors where resources remain good, while much of the surrounding land turns harsh. Migration sounds simple on a map. Arrows flowing from cold to warm, from dry to wet. But for real communities, it means something more fragile, broken chains of continuity. The sacred grove you returned to each year, gone or cut off by a glacier-fed river in flood. The burial grounds of your ancestors, left behind as you shift camp one valley, then 2, then 10 valleys away. The trade partners you counted on for obsidian, shells, pigments, knowledge, separated from you by new deserts, new ice, unfriendly groups who got there first. Stories can travel, techniques can travel, but physical traces are much more rooted. When populations disperse, shrink, or are forced into marginal refuges, they leave fewer durable marks in the places they abandon. Over tens of thousands of years, those places can be scraped by ice, buried by loess, eroded by rivers, or simply covered by new soils and new forests. Abrupt climate shifts also stress social fabrics directly. Crop failures in early farming communities, pasture degradation for herders, sudden shortages of key wild foods for hunter-gatherers. Even a small increase in the frequency of bad years can cascade into chronic malnutrition, disease, and conflict. We can see this pattern in more recent, better documented episodes. Droughts helping to destabilize Bronze Age societies in the eastern Mediterranean. Multi-year failures of the Nile flood contributing to political stress in ancient Egypt. The so-called Little Ice Age amplifying famine and unrest in early modern Europe and Asia. For deeper time without written records, the signals are subtler, layers of charcoal hinting at increased burning, shifts in the kinds of pollen preserved in lake mud, marking forests thinning into grassland or scrub, abrupt interruptions in the occupation layers of archaeological sites, one period of dense activity, then a gap, then a different kind of material culture appearing later. These are not smoking guns for the fall of advanced civilizations in the sense we know today. What they do show is that climates capable of pushing even simple societies to relocate or reorganize have been a recurring feature of the last 100,000 years. And they remind us that the absence of continuous remains in one place does not mean the people themselves vanish. They may have thinned out, scattered, merged with neighbors, or shifted their centers of activity to zones that are now hard for us to access. Steep uplands, deserts that were once greener, continental shelves that are now under the sea. Climate proxies are our main guides to these lost environmental worlds. Ice cores, with their fine-scale record of temperature and atmosphere. Pollen grains, trapped in the quiet sediments at the bottoms of lakes and bogs, telling us what plants dominated a landscape at any given time. Tiny shells of plankton in seafloor muds, whose chemistry shifts with ocean temperature and acidity. Tree rings in the shorter term expanding and narrowing with good years and bad. Put together they reveal scenes we can barely imagine. Europe as cold open steppe, dotted with mammoth and reindeer. The Sahara pulsing between desert and savanna with lakes. Monsoon belts sliding north and south, turning some regions into seasonal paradises for a few thousand years and then withdrawing, leaving desiccated basins where rich wetlands used to be. Any human groups, simple bands or more complex networks, living in those sweet spots would have ridden a moving wave. When the climate belt shifted, their home base moved with it, or they paid a price. If someone at some time built something more intricate than we expect under those conditions, a web of seasonal hubs, a ritual landscape, a chain of trading centers, it would have been pinned to a particular set of environmental boundaries. Forest edge here, grassland there, river flow reliable but not too wild. Tilt the climate, slide the belts, and that whole pattern can dissolve, not in an explosion, but in a long, ragged fade-out. Later peoples might wander through the same valleys under a different sky, with different animals, different plants. They might never know that this was once a core, a center, a place where earlier minds had gathered and built and told each other they were living at the heart of the world. From our vantage point we see fragments, a scatter of tools in an unexpected place, a sudden change in pottery styles, an unexplained abandonment of a once flourishing site. From the planet's vantage point, it is just the climate doing what it has always done, testing, shifting, rewarding flexibility, punishing rigidity. Ice grows and retreats, rains move, habitable zones glide across the map. Populations follow, collide, or fade. For any delicate experiment in complexity, that moving target is as dangerous as any flood or earthquake. Which brings us to the moments when climate stress and sudden catastrophe line up, the times when the background strain of change meets a single violent blow. When people imagine the end of a civilization, they often picture one big event, a wall of fire on the horizon, a wave swallowing the coast, a rock falling from the sky. Reality is usually messier. Societies fray, adapt, move. Decline is often a long slope, not a cliff. But sometimes there really is a cliff. And when it comes, it does something very important for our question. It acts like a reset button. It can wipe clean whole regions of the archaeological record in a way that, thousands of years later, looks less like interrupted history and more like nothing was ever here. Volcanoes are among the most efficient reset buttons the planet has. A big eruption is not just a pretty plume of ash, it is a machine for erasing landscapes. First, the ash. Fine, glassy particles lofted kilometres into the sky, then settling out over days and weeks. In the near field, ash doesn't just dust the ground. It buries it. Tens of centimetres, metres, in extreme cases even tens of metres. Roofs collapse under the weight, plants suffocate, streams clog. Whole ecosystems are not just killed, they are sealed. Then there is lava. People sometimes imagine flows as slow, glowing rivers you can calmly walk away from. Some are like that, others are fast enough, and wide enough to engulf fields, forests, and towns in a single night, leaving behind a black, cooling sheet of basalt. Under that sheet, whatever was there before becomes part of the basement. Wooden structures are incinerated, stone walls are toppled and baked. Roads, fields, and courtyards vanish under a surface that to later eyes looks like natural rock. Most devastating of all are pyroclastic flows. These are not really flows in the ordinary sense. They are avalanches of ash, gas, and shattered rock, moving at highway or even jet plane speeds, at temperatures high enough to char flesh in an instant. They hug the ground, follow valleys, pour through gaps. They don't politely go around human settlements, they go through them. Where a pyroclastic flow passes, it can scour the ground, topple buildings, and fill low areas with a dense, hot slurry that hardens into something like stone. In the geological record, these show up as tough layers, welded ash beds, ignimbrites. In human terms, they are, everything here died, and then everything was buried. We know this not just in the abstract, but from places like Pompeii and Herculaneum, frozen in the act of living, then entombed. And this is where volcanoes become double-edged for memory. The same eruption that obliterates also preserves. Pompeii was covered in meters of ash and pumice. Roofs crashed, people died, streets vanished. But under that burial, fragile things survived that almost never make it through time. Wooden doors, food, graffiti, wall paintings, even loaves of bread in ovens. As the ash hardened and turned to rock, it protected those layers from weather, from scavengers, from later construction. Archaeologists centuries later can walk those streets, read those curses and jokes, peer into the shapes left by vanished bodies. On a small scale, catastrophic burial is one of the best preservers we know. But that's the key, on a small scale. Pompeii is famous precisely because it is unusual. Most volcanic disasters do not produce a neat, sealed time capsule. They obliterate without conveniently wrapping the remains for future study. If an eruption buries a site under 10 meters of ash, and that site itself was built mostly of wood, that's the end of the story, unless someone much later digs that deep by chance or for some other purpose. If that ash is then eroded, reworked, covered by other sediments, the original occupation surfaces may be scattered beyond recognition. Scale matters too. A civilization that put many of its core activities on or near fertile volcanic slopes might see not just one town destroyed, but a whole cultural heartland. Repeated eruptions over a few centuries could keep forcing people to abandon and rebuild, each time mixing, burning, and burying earlier layers. Viewed from 10,000 years away with limited trenches and scattered exposures, that could easily look like this area was sparsely used instead of this area hosted multiple dense, complex communities that kept getting knocked back. Water has its own reset buttons. Tsunamis, those long, low waves that rise into terrifying walls only near shore, are especially important for any seafaring or coastal society. Most humans today cluster near coasts. It is an old pattern. Shorelines offer fish, transport, salt, flat land, and access to river mouths. If you were ever going to build something like an early maritime civilization, harbours and estuaries would be obvious places to choose. They are also perfect targets for tsunamis. A large undersea earthquake, a submarine landslide, even in rare cases a volcanic flank collapse, can send vast pulses of water racing across ocean basins. In deep water, they may be barely noticeable. In shallow water, they slow, compress, and rise, sweeping far inland, shredding anything built near the coast. Wooden houses? Gone. Boats? Tossed into fields or smashed to fragments. Stone structures? Undercut, undermined, overwhelmed by debris. When the water retreats, it pulls much of that debris back out. What remains on land may be chaotic piles of rubble, silt, and vegetation, spread over a wide area. A tsunami deposit in the geological sense might be a layer of sand and pebbles a few tens of centimetres thick, overlain and underlain by ordinary soils. If the buildings were modest, organic, and repeatedly rebuilt, the tsunami's signature in the archaeological record can be subtle. An odd sand layer, some disarticulated bones, broken pots, shells in the wrong place. Now overlay time, coasts migrate, sea levels rise and fall with ice ages. River deltas grow outward, burying old shorelines under kilometres of mud. Many of the most attractive ancient waterfronts are now tens of metres underwater or buried under modern cities. A seafaring culture knocked flat by a tsunami, then thinned out by famine and disease, might leave only a few drowned harbour structures, now deeply submerged. Its boats would rot, its wooden piers would vanish. Its stories might survive, mutating into myths of a great flood, a stolen coastline, gods angry with human pride. From our perspective, probing a few accessible bays and inlets, we might find almost nothing. Just as in the Bronze Age Eastern Mediterranean, the sea peoples appear in Egyptian records like a sudden, violent interruption, and elsewhere barely at all. Then there are the impact scares. The idea that a comet or asteroid might have wiped out an advanced culture before ours is a favourite of speculative histories. It's dramatic, it's cinematic, and we know that big impacts have happened before. The dinosaurs did not imagine the rock that ended their world. So what would we actually expect to see if a civilization-ending impact had occurred in the last few 100,000 years? Large impacts leave signatures that are hard to miss once you know to look for them. A crater of the right size and age, with the characteristic structure, a raised rim, shocked rocks, sometimes a central uplift, minerals displaying shock metamorphism, quartz grains deformed in ways that only extreme sudden pressures can produce. Global or regional layers, rich in tiny glassy spherules, condensates from molten rock thrown high into the atmosphere, spikes in certain elements like iridium, unusually abundant in some meteorites. We have found such signatures for older events. Chicxulub, 66 million years ago, linked to the end Cretaceous extinction, a cluster of craters and ejecta layers from earlier periods. For the last few 100,000 years, though, the known impact craters are either too small to have global effects, or so old and eroded that any link to human cultures would be hard to pin down. There are controversial claims about more recent impacts influencing climate events like the Younger Dryas, but the evidence there is still debated. No consensus smoking crater tied to a vanished high civilization has emerged. That does not mean no moderate impacts occurred over inhabited regions. Smaller airbursts, like the 1908 Tunguska event in Siberia, which flattened a forest over thousands of square kilometres, leave very little geological trace. A city under that kind of blast would be gone. An entire region could be devastated. Memories of such an event might echo as fire from the sky myths for millennia. But in the physical record, a Tunguska-style event 50,000 years ago over some coastal plain might leave almost nothing we could easily detect now, especially if subsequent rivers, seas, and sediments have reworked the ground. This is the pattern with catastrophe. Volcanoes, tsunamis, impacts. They all have this two-faced nature. Up close in time they are unforgettable. They fracture calendars, religions, dynasties. People remember before the mountain blew, before the wave, before the sky burned. Far away in time, they either preserve exquisite moments in amber, like Pompeii, or they act like giant erasers, resetting surfaces, scattering traces, making it look as if human presence simply stopped, or was never significant to begin with. Archaeological records are often read as if they are continuous scrolls. Layers stack neatly, cultures change gradually, absences are assumed to mean absence. But in many regions, what we are really looking at is more like a palimpsest. Pages written on, scraped off, written on again, sometimes with fire, sometimes with water, sometimes with rock from below or above. A regional civilization, whether simple or surprisingly sophisticated for its time, that grew up on a coastal plain, beneath a restless volcano, or along an impact-prone stretch of sky, could be scrubbed from that palimpsest in a geological instant. Later groups might move in, build on the same general land, unaware that they were walking on buried streets or fields. To us, their remains would be the earliest visible marks. Everything before would be hidden under the reset layer. When we talk about lost worlds or missing civilizations, we don't need to imagine global annihilation to explain their absence. We just need to remember how efficiently the planet occasionally hits its local reset buttons, and how small a fraction of its overwritten pages we have actually learned to read. So far, we've been talking mostly about the big forces. Ice, fire, water, rocks from the sky. But there's another, quieter eraser at work, one that never sleeps. The simple fact that most of the stuff we think of as advanced is terrible at surviving deep time. If you want to hide a civilization, you don't have to vaporize it. You just have to wait. Think about our own world. We like to picture our cities as permanent things. Skyscrapers of steel and glass, highways of concrete, oceans full of plastic, a whole planet wrapped in electronics. But none of this is timeless. All of it has a clock. Take concrete. Modern concrete is strong in compression, weak in tension, and always cracking. Water seeps in. In cold climates it freezes and thaws, prying those cracks wider. Salts migrate through it. Reinforcing steel inside begins to rust, expanding as it does, bursting the concrete from within. Bridges, dams, towers. Without constant maintenance, they do not become eternal monuments. They spall, crumble, and return to gravel and dust. Give an ordinary concrete building a century without repairs, and it starts to sag and break. Give it 10,000 years, and what's left is a low, weathered mound, barely different from the natural rubble around it. After 100,000, it merges with the sediments completely. Steel is no better. Steel is just iron, carefully alloyed and heat-treated. Expose it to oxygen and water, and it wants to go home to rust, to iron oxide, the state it prefers in nature. Corrosion is not gentle. It doesn't quietly patina the surface and stop. In the presence of moisture, especially salt water, rust can eat through beams and plates astonishingly fast. Ships abandoned at sea break apart within decades. Oil platforms left to the waves twist, collapse and topple. Bury steel, and microbes join the attack. Certain bacteria actually breathe metal oxides, feeding on the corrosion process. Underground pipelines, if not perfectly protected, develop pits and holes in just a few human lifetimes. Extend that out to geological time, tens of thousands, hundreds of thousands of years, and you're not talking about rusty relics. You're talking about traces of trace elements, maybe a subtle chemical anomaly in a soil layer, nothing that screams skyscraper. Plastics feel more ominous because they are so persistent on human scales. Bags, bottles, fishing nets drifting for decades, maybe centuries. But plastics also decay. Sunlight breaks their long chains. Waves grind them into fragments. Microorganisms are slowly evolving to chew them up. Over long spans, plastics don't remain as intact artifacts. They become microplastics, then nanoplastics, then carbon and hydrogen redistributed into other compounds. It is possible that millions of years from now, a thin layer rich in odd polymers or their breakdown products will mark the Anthropocene. But that's not the same as a plastic cup, or a phone or a toy surviving to be held in someone's hand. Electronics are worse. Computer chips, circuit boards, displays, all of these are delicate sandwiches of metals, plastics, ceramics and glues. Expose them to heat, moisture, mechanical stress, and they fail quickly. A smartphone dropped in a forest is not a time capsule. Its battery swells and leaks. Metals corrode. Plastics crack. Organic components are attacked by fungi and bacteria. Within a few hundred years, most of it is dust and dispersed metal ions. Within a few thousand, only tiny, unremarkable bits of ceramic or glass might remain, indistinguishable from natural grains. And that's assuming nobody picks it up first. Because another big problem for preservation is us, or whatever intelligent beings come after. Abandoned cities don't just sit there. They get mined. Later people move in, see piles of cut stone, lumps of metal, strange artifacts, and they do the obvious thing. They reuse them. We see this clearly in history. Roman temples stripped to build medieval churches. Bronze statues melted down for coins and cannon. Old walls quarried to make new houses. In many ancient sites, almost no workable metal is left at all, not because it never existed, but because it was too valuable to abandon. The archaeological layers we find are often the crumbs that couldn't be recycled, broken ceramics, worn-out tools, things too small or too inconvenient to salvage. Now imagine a collapse that lasts not centuries, but millennia. Generation after generation, people return to the ruins of a once advanced culture, scavenging metal from vehicles, wiring from buildings, structural beams from bridges. They break apart machines they don't understand, keeping the parts that are obviously useful: blades, nails, bars. By the time a new, stable society appears on the same land, most of the old material has been melted, reforged, recast into tools whose shapes no longer hint at their origin. A modern turbine blade might end up, centuries later, as a dozen ordinary knives. To an archaeologist, thousands of years after that, those knives look like simple metal tools from a low-tech culture. The sophisticated thing they once were a part of has been erased by recycling. Fires and rebuilding accelerate this erasure. Urban fires are notorious in history. Wooden roofs catch. Stored fuel ignites. Whole districts burn. In the process, many of the most telling artifacts, books, textiles, fine wooden objects, vanish first. Then come the rebuilders. They level the charred remains, raid the rubble for usable stone, and throw the rest into fill. Foundations get dug deeper, crushing older floors. Wells are cleaned and reused, mixing centuries of deposits. Every new construction project is also a small act of destruction, blurring the past beneath it. Over many cycles of burning and rebuilding, a city's early phases can be reduced to a compressed, jumbled layer. Instead of neat, readable strata, you get pits, cuts, dumps, and surfaces sliced by later walls. The diagnostic things, the inscriptions, the specialized tools, the oddities that might make you say this was something different, are precisely the ones most likely to be reused, looted, burned, or broken first. This is why, in the very long run, stone is king. Stone monuments survive not because they are particularly advanced, but because they are stubborn. They don't rust. Many of them resist dissolution. They are too big to recycle easily and too heavy to carry off completely. Pyramids, megaliths, carved temples. These are the celebrities of deep time because they play well with weather and neglect. Even then, they soften, slump and sink. Faces blur on statues. Inscriptions fade. Walls collapse after 100,000 years of freeze-thaw and root pressure. Even a pyramid could be reduced to a strangely regular hill. And stone is the exception. Most sophisticated things, electronics, composites, engineered polymers, reinforced concrete, are made to perform brilliantly for decades, occasionally centuries, not for geologic ages. They depend on complexity, tight tolerances, and specific environments. Take away the maintenance, the power, the people, and they begin to fall apart. If a technically capable culture had flared and faded 100,000 years ago, its stonework, if it favoured stone at all, would have the best odds of making it to us. Its metals would mostly have returned to oxides, scattered through soils. Its plastics and synthetics would be long chewed, crushed, and chemically altered. Its cities, if they were concrete and steel, would be softened into odd eroded ridges, buried under later sediments, mistaken for natural features unless sliced open in just the right place. To recognize such a world, we would have to be very lucky or very thorough, because the materials we associate with advanced are, ironically, some of the worst storytellers in the Museum of Deep Time. And that brings us to another difficulty. Even if traces exist, we only notice certain kinds of traces, from certain kinds of materials in certain kinds of places. Our archive of the past is not neutral. It is biased, filtered, and patchy. To ask whether earlier advanced societies might have slipped through our nets, we have to ask not just what they built, but how we look for them in the first place. Archaeology sounds reassuringly scientific. We picture grids of string, careful trowels, little brushes revealing the past grain by grain. It feels systematic, exhaustive, almost all-seeing. It isn't. What we call the archaeological record is not everything that ever happened. It's everything that has survived in the places we've happened to look, using the tools we currently have under the rules and budgets of our own moment in history. It's a sample, and not a random one. First, there's the problem of visibility. Archaeologists can only start with what they can detect. That means things that stick out of the ground, things that disturb the surface, things that show up clearly in aerial images or satellite scans. Big stone walls, mounds, ditches, dense clusters of pottery or brick. We're good at finding those. We're much worse at finding low relief, deeply buried, or subtle sites. A small settlement under 10 meters of floodplain silt does not wave its arms at a survey team. A collapsed harbour now under 30 meters of murky water does not advertise itself on a stroll along the beach. So our maps of where people lived are really maps of where past activity happens to still be near the surface, in open ground, in places we bothered to check. Then there's access. Some parts of the earth are thick with excavation trenches, radiocarbon dates, and published reports. Western Europe, parts of the Mediterranean, a few well-funded regions in the Near East, China, the Americas. Other areas are almost blank on the archaeological map. Not because nothing ever happened there, but because they're covered in dense forest or deep alluvium or modern development, or they're politically unstable or simply not considered interesting in the current research fashion. Funding follows certain narratives: the birth of agriculture, the rise of cities, famous empires, monumental stone. You get money to dig at a place that might be the oldest something, the oldest temple, the oldest city, the oldest burial. You get less money to test a random flat field in a floodplain that, for all anyone knows, might hide 10 vanished villages under 20 meters of mud. Permits add another layer of filtering. Excavation is slow, destructive, and regulated. Local laws, landowners' wishes, religious sensitivities, national politics, all of these decide what can and cannot be touched. Some ancient mounds sit under protected shrines, some potential sites underlie busy airports or highways. Others belong to communities justifiably wary of outsiders digging up their ancestors' graves. So even if we know or suspect something is there, we may never get to test it. Now add a simple but brutal fact. Modern cities often sit right on top of ancient ones. This makes sense. Good harbours stay good. Fertile river junctions stay fertile. Cool hilltops with fresh springs stay attractive places to live. In places like Cairo, Rome, Mexico City, Baghdad, layers of past settlements stack up under the asphalt. Meters and meters of walls, streets, houses, trash pits, workshops. Each era built on the ruins of the last. To really read that whole story, you'd have to peel the modern city away like an onion, slice the ground in 100 places, and leave people homeless while you do it. We don't do that. Instead, archaeology piggybacks on construction. A subway line, a parking garage, a foundation excavation bites into the older layers, and if you're lucky, someone calls the archaeologists before the concrete trucks arrive. What we get are narrow windows, a trench here, a pit there, a basement shaft over there. Imagine trying to reconstruct a whole library's contents because you've seen pieces of a few pages, scattered in random spots. That's the reality under many of our biggest, most continuous centres of habitation. And even when we do get to dig, the record can be damaged before we ever see it. Looting pulls artifacts out of their layers and scatters them into the black market. A pot in a collector's cabinet may be beautiful, but stripped of context. What it was found with, how deep, in what kind of structure it says far less than it could have. Conflict shreds sites. Artillery craters churn trenches from earlier ages. Fortifications cut through cemeteries. Tanks and bulldozers tear up. Tells that took millennia to build. In some wars, sites are deliberately targeted, blown apart for ideology or profit. Peaceful development isn't gentle either. Road building, irrigation schemes, industrial parks, mines, all of these move huge volumes of earth. Without careful survey ahead of time, a whole stratified record can be scraped off in a season and turned into gravel or fill. In all these cases, the things most attractive to looters and builders, the big, useful or obviously valuable materials, are exactly the things that might signal complexity. Inscriptions, metal tools, unusual alloys, fine carving. They get removed, reused, stolen, melted down, or broken. What remains, if anything, may look like a modest scatter of pottery and rubble, the archaeological equivalent of crumbs with the cake gone. On top of that, interpretation itself is not fixed. Dating methods improve. Radiocarbon calibration curves get revised. New techniques like optically stimulated luminescence or improved isotope analysis arrive and quietly move timelines around. Sites once thought to be from one period are redated, pushing origins back or forward by thousands of years. Early agriculture, early symbolic behaviour, early seafaring, all of these have seen their earliest known dates shift as new methods and new finds come in. The same artifact can mean different things in different theoretical climates. A strange carved object might once have been dismissed as a ritual trinket, later reinterpreted as a tool, later still as evidence of complex planning or abstract thought. Whole cultures have been reimagined as our own assumptions change. Peaceful farmers become competitive chiefdoms, simple hunter-gatherers turn out to have rich trade networks and sophisticated environmental knowledge. Underneath all this is uncertainty. Every radiocarbon date has an error range. Every stratigraphic interpretation has alternative readings. Every absence of evidence can be, "we haven't found it yet," or "it was never there," and the two are not easy to disentangle. That's why debates in early history and prehistory persist. Was this really the first city, or just the first one we've excavated deeply? Did writing begin here, or did we simply miss a short-lived experiment somewhere else? Were these people isolated, or did they have contacts we haven't traced, because their seafronts are now underwater and their trade goods were perishable? Archaeologists are aware of these biases. Many spend their careers trying to correct them, surveying off the beaten path, using remote sensing to peer under forests and fields, prioritizing boring places like old floodplains or featureless plains. But for our purposes, one point matters. When we look at the past and say we see no sign of a certain kind of society before a certain date, we are not speaking with the authority of a complete archive. We are speaking from a partial, damaged, selectively sampled record, filtered by visibility, access, funding, politics, and technology. For reconstructing normal human history, this is often good enough. The broad strokes hold. But if we're asking a more unsettling question, could something complex have risen and fallen in a way that slips through these filters, then the biases of the archive become part of the story. They don't prove such a civilization existed. They simply remind us how easy it can be for entire worlds to be built, lived in, destroyed, reused, and buried, leaving only faint, contested traces at the very edges of what we happen to see. And if written records are fragile, and artifacts are patchy, there's one more thing we have to consider: memory itself. Because human beings don't just leave stones and bones behind. They leave stories. Tales of floods, fires, strange visitors, lost ages. The question is how far those stories can reach, and what, if anything, they might still be remembering. Before there were chronicles and clay tablets, there were voices. Around fires, in caves, in huts of grass or stone, people told each other what had happened, who they were, where they had come from, what to be afraid of, what not to do again. Those stories are older than writing, much older than any intact ruin we've ever dug up. So when we ask whether something advanced might have risen and fallen before the earliest scripts we know, we have to ask another question alongside the archaeological one. If it did, could any echo of it survive in myth? We know that oral tradition can carry real information a surprisingly long way. In Australia, some Aboriginal groups tell stories about coastlines that no longer exist, places where the sea is said to have come in and swallowed hunting grounds, freshwater springs, even specific features of the landscape. Geologists have mapped those submerged coastal shelves. Sea level models suggest those floods happened 7, 8, even 9,000 years ago, at the end of the last ice age. Yet the stories are still there, linked to real geography, passed along in ceremonial songlines, generation after generation. Along the Pacific coast, some indigenous groups preserve tales of great waves that came without warning, swallowed villages and left canoes hanging in trees. In Japan, there are shrines that mark how far inland the water once reached. When geophysicists overlay those sacred markers and stories with the geological traces of tsunamis, they often line up. The myths are not detailed technical reports. They don't list fault line angles or wave heights. But as warning systems, as cultural memory of this happened here, it can happen again. They work. Myths can also encode geography in more subtle ways. A ladder to the sky might remember a mountain pass that once led to an important trade route. A river that flows backward might mean a strange local current, a tidal bore, an estuary that floods inland instead of out to sea. When you depend entirely on your environment, it makes sense to bury practical knowledge inside sacred stories. Children will remember a frightening tale long after they've forgotten a dry list of directions. And myth is good at storing rules. Don't fish in this season. Don't cut those trees. Don't build in that valley. Don't eat that plant unless it's prepared exactly this way. Instead of saying because of erosion or because of toxins, the story says because the spirits there are dangerous or because that's where the ancestors drowned. The logic is emotional, symbolic, but the behavioral outcome is concrete. Avoid the floodplain that killed your great-grandparents. Respect the forest that keeps the hillside from sliding onto your village. So myth can be a kind of encoding, of disasters, of landscapes, of social arrangements that worked well enough to be worth preserving. But there are limits. Stories drift. Every telling is slightly different. Details get polished for drama or simplified for a child. Characters merge. Episodes that once belonged to different events get stitched together into one big saga. We can see this even in written myths. The same flood in Mesopotamia appears with different heroes, different gods, different motives as the story is retold over centuries. A local river flood becomes, in time, a world-destroying deluge. A city wiped out becomes all people wiped out. Oral tradition amplifies this flexibility. Without a fixed text, small mutations can accumulate quickly. Over 5 generations, you might still recognize the core of an event. Over 50, you might be dealing with something that shares a skeleton, but has grown new limbs. And beyond a certain time depth, it becomes very hard to know what, if anything, in a myth corresponds to a specific historical moment. 10,000 years, 20. At that scale, ice sheets come and go. Lakes appear and vanish. Volcanoes grow mountains and then erase them. Stories adapt to each new audience, each new crisis. Old frameworks get reused to explain fresh disasters. A memory of one real flood might end up absorbing 3 or 4 later ones into itself. This is where the idea of cultural bottlenecks comes in. We've talked about genetic bottlenecks, moments when most of a population dies, leaving only a few lineages to carry the species forward. Cultures can bottleneck too. Imagine a complex society with many traditions, dialects, taboos and tales. Then imagine war, famine, plague, or climate shift wiping out most of its communities. A few groups survive, maybe in marginal refuges. They carry some fraction of the old stories, but not all of them. They simplify. They forget names. They fold several separate cities into the great city. They turn a whole chain of wars into a single battle between gods. Later, those survivors migrate. They meet other people. They intermarry. Their stories mix with those of neighbours, just as genes mix. After a few such cycles collapse, survival, migration, fusion, you can have myths that genuinely contain kernels of very old events, but buried under many layers of retelling, recombination, and metaphor. Like sedimentary rock, but for memory. That's why myths are double-edged tools when we think about lost worlds. On one side, they can point us toward hypotheses. If many unrelated cultures around a particular ocean basin tell tales of a drowned land to the east, or a time when the sun was hidden for months, that can nudge geologists and archaeologists to check for submerged plains, volcanic eruptions, impact craters. Sometimes physical evidence turns up that fits the general pattern. On the other side, myth is not proof. For any theme you can imagine, floods, sky fire, golden ages, beings from elsewhere, you will find stories. Humans are creative. Our minds converge on certain images because of shared psychology, not necessarily shared history. We fear water and darkness and hunger. We dream of lost abundance. We personify storms and comets because they are powerful and unpredictable. So a story about a shining city that fell into the sea could be the distant echo of a real coastal town destroyed by a Holocene tsunami. Or it could be an entirely invented cautionary tale about arrogance and loss spun by people who lived their whole lives inland. The story alone can't tell you which. To move from myth to history, you need something harder. Dates, layers, sediments, artifacts that anchor the tale to specific times and places. Until then, myths live in a liminal space. They matter because they shape where people live, what they avoid, how they respond to danger, and because they hint, sometimes at events that left no easy trace. They can widen our imagination about what to look for and where. But if we're trying to decide whether advanced civilizations rose and fell before the ones we know, we have to let myth be what it is: suggestive, evocative, full of possible memories, and always filtered through the human need to make meaning rather than to keep records. To see how this plays out in real history, we can look at collapses we actually understand. Times when complex societies definitely did fall apart, and watch what stayed, what vanished, and how their stories survived or didn't into the ages that followed. When we talk about collapse, it's easy to imagine something sudden and total: cities burning, populations vanishing, a world switching off like a light. The real story, most of the time, is quieter, messier, and much more useful for our question. Take the classic culprits that show up again and again in collapse studies: long droughts that grind down harvests year after year. Not one bad season, but 10 or 50, until granaries empty and people stop trusting that next year will be better. Trade routes that break, a key caravan road becomes unsafe, a sea lane fills with pirates, or a foreign power conquers one choke point, and suddenly the copper or tin or grain your city depends on just doesn't arrive. Internal strain. A palace that demands more labour, more taxes, more soldiers from people who are already stretched thin. Elites fighting each other while the fields go untended. Outbreaks of disease that move along those same trade routes that once brought wealth. Plague in crowded, mobile, interconnected societies can be devastating in a way that scattered villages rarely experience. War and raiding layered on top of all this. Neighbour against neighbour, city against city, all competing for shrinking resources. Most famous collapses are not caused by one of these alone, but by several in combination. The classic Maya, for instance, don't vanish in a single apocalypse. Over a couple of centuries, inscriptions thin out. Stelae stop being carved. Great cities in the southern lowlands are gradually abandoned. Pollen records and lake sediments suggest deepening drought. Isotope studies and house remains hint at nutritional stress. There are signs of increased warfare, hastily built fortifications, disrupted trade. From the ground, for the people living through it, this probably felt like a slow tightening. From the perspective of archaeology, especially if you're looking back from 1,000 years later, it can look like an abrupt silence. One layer of rich material culture, sculpted monuments, painted pottery, and above it, much thinner deposits, simpler goods, fewer buildings. A vanishing. Something similar shows up in the late Bronze Age Eastern Mediterranean. For centuries you have palatial states, Mycenae, Ugarit, the Hittites, New Kingdom Egypt, linked by ships and scribes and letters written on clay. Then, in the span of a human lifetime or two, many of those centres burn or are abandoned. Trade in luxury goods collapses, writing systems disappear or drastically contract. To someone walking through those ruins a generation later, it might have felt like the end of the world. To us, piecing together what happened, the pattern looks familiar. Earthquakes, possible droughts, shifts in military technology, attacks by displaced populations, internal revolts. A dense, fragile network that couldn't absorb so many shocks at once. But here's the important part for our question. Even in these dramatic cases, very little truly disappears without a trace. What you tend to lose first are the obvious symbols of complexity. Palaces are abandoned or repurposed. Administrative centres fall idle. Monumental building stops. Fine imported wares cease to arrive. Texts are especially fragile. Archives burn. Wooden tablets rot. Papyrus disintegrates. Clay survives a bit better, but only if it gets baked hard in a fire or kiln and then reburied somewhere safe. When libraries and temples are destroyed, generations of accumulated knowledge can go with them. Entire schools of astronomy, medicine, engineering wiped out in a few days of chaos. What hangs on are the things that are too ordinary to attract attention or too small to be worth looting. Farmsteads on hillsides, little hamlets tucked into marginal valleys, field systems that get reused with minor changes, pottery that continues to be made in simpler, local styles. From a distance of millennia, the record is skewed. The spectacular face of a civilization, its capitals, its monumental art, its bureaucratic archives, is exactly the part most likely to burn, collapse, or be quarried away for building stone. The parts that endure in the ground are often the less advanced looking. Small houses, coarse ceramics, worn-out tools. If you were trying to decide whether some earlier age had ever built something like a Bronze Age palace system, and all you had to go on were scattered farmsteads and the occasional undeciphered shard, you might easily underestimate what had once been there. But collapse is not just about loss, it's also about continuity. People survive, they move, they marry, they remember in their own way. After the Bronze Age crisis, new societies rise in Greece, in the Levant, in Anatolia. They inherit bits and pieces, reused building sites, fragments of myth about former heroes, loanwords from dead languages embedded in religious vocabulary and place names. After the fall of the Western Roman Empire, the big fiscal machinery of empire disintegrates in many regions. Armies fragment. Urban life contracts. Yet Latin continues, warps, splits into Spanish, French, Italian, Portuguese, Romanian. Roman roads are still walked. Roman law echoes in later codes. Christianity, once a persecuted sect within the empire, becomes one of the main conduits through which scraps of Roman thought survive. Collapse reshapes identity. A peasant who once thought of themselves as a subject of a king may, 2 generations later, think of themselves as part of a tribe or a faith or a village lineage instead. Languages drift. Old ethnonyms vanish. New ones appear. Outsiders, centuries later, might have no idea that the new people in a region are largely descendants of the old ones under a different name. This is crucial when we think about very ancient or hypothetical advanced cultures. We don't have to imagine exotic, unprecedented mechanisms to explain how a complex society could largely vanish from easy detection. We can look at mechanisms we already see: environmental stress leading to migration and abandonment, trade networks unraveling, isolating regions that once shared a common material culture, literacy restricted to tiny elites, then lost when those elites die or flee, technologies simplified because the surplus and specialization that supported them no longer exist. Each step leaves traces, but those traces are thin, scattered, and biased toward the mundane. What remains in the ground is not the civilization, but whatever bits of it happen to be made of durable stuff in the right places and not reused by later builders. What remains in language and story is not a chronicle but echoes. A flood myth here, a memory of a golden age there, a handful of strange words whose ancestors once named forgotten institutions. When we use known collapses as templates, we're not proving that earlier advanced worlds existed. We're doing something more modest and more reliable. We're learning how much can be lost, how fast, and what kinds of fingerprints even a shattered society still tends to leave behind. Those fingerprints, subtle changes in soils, odd distributions of artifacts, unexplained technological jumps or gaps are what we'd expect to see if something big had risen and fallen before our familiar timeline. To look for them, though, we need a clear idea of what an earlier advanced culture would have been made of, and which parts of it would stand any chance at all of surviving deep time. Whenever we talk about vanished worlds, another set of characters sneaks into the story. Atlantis, ancient high-tech. Civilizations erased by a global cataclysm, leaving only whispers in myth and a few out-of-place artifacts. These ideas are sticky. They show up in novels, documentaries, late-night conversations, online rabbit holes. They refuse to die, no matter how many times they're debunked. Why? Part of it is simple psychology. We don't like loose ends. When we see gaps, mysterious ruins, undeciphered scripts, sudden changes in the archaeological record, our brains want a clean, dramatic answer. A forgotten global civilization feels more satisfying than a slow, messy process we don't fully understand yet. There's also a deeper pull. The notion that we are not the first taps into something almost mythic. It echoes religious cycles of ages and destructions, golden worlds and great floods. It makes our own time feel like one chapter in a much longer story, instead of a fragile fluke. And quietly these ideas flatter us. If an earlier civilization reached great heights and then fell, maybe our own power and knowledge are less secure than we think. That's frightening, but also a little thrilling. It turns everyday life into the aftershock of some enormous forgotten drama. So when people talk about Atlantis or impossible ancient engineering or electrified pyramids, they're not just talking about stones and dates. They're talking about meaning, about where we fit in deep time. But if we want to take those questions seriously, we need tools sharper than that looks cool or that feels ancient. Archaeology, geology, and history use some fairly simple but powerful filters for judging claims about lost civilizations. One is provenance. Where exactly did this object or inscription or structure come from? Who found it? Under what conditions? Can that story be checked? An artifact dug up in a documented excavation, with records, photos, and multiple witnesses, is very different from something that turned up in a private collection with no clear trail. Provenance is the chain of custody that lets you tell whether you're dealing with genuine deep time or something that could have been planted last week. Another is context. Objects by themselves don't tell you much. A carved stone, a metal rod, a strange crystal. All of these could be ancient, modern, or somewhere in between. Context is everything around them. The soil layers, the associated bones and pottery, the nearby structures, the sediment that buried them. When an artifact is found in situ, in a sealed layer with lots of other material that can be dated and cross-checked, you can start weaving it into a solid story. When something is ripped out of context by looters, by untrained diggers, by treasure hunters, you lose that story. You keep the mysterious object, but throw away the only clues that could solve the mystery in a reliable way. Then there's dating. For very old things, no single dating technique is perfect. But when you can use several radiocarbon, thermoluminescence, uranium series, paleomagnetism, and they all converge on the same age, your confidence grows. When a mystery artifact is never subjected to any independent dating at all, or the results are never published in peer-reviewed form, that's a red flag. Provenance, context, replicable dating, claims about hidden high technology or pre-Ice Age empires that bypass all three are not being evaluated by the same rules that we apply to everything else we know about the past. They're asking for a special exemption. There are also some very common traps that fuel lost civilization stories. Natural geology is one of the big ones. Rock wants to look like architecture. Erosion carves right angles, straight lines, terraces, even pillar-like shapes. Lava freezes in hexagonal columns. Waves and currents scour flat plains and sharp steps into coastal shelves. From ground level, or especially from a blurry photo, it's easy to see walls, pyramids, roads, where a geologist sees bedding planes, joints, and fractures. Another trap is modern intrusion. Old sites are rarely pristine. Farmers cut drainage ditches through ancient layers. Miners dig shafts. Cables and pipes are laid. People build over ruins, reuse stones, drop trash. If you don't track those recent disturbances carefully, you can end up with a medieval nail in a Bronze Age layer, or a plastic fragment in an otherwise ancient deposit, and suddenly someone is claiming time travel or impossible technology when it's really just contamination. There are also more subtle interpretive pitfalls. Underestimating what known ancient cultures could do with the tools and materials they had. Overestimating how much advanced technology would actually leave a durable mark. Reading metaphorical myths as literal historical journalism. This doesn't mean everything speculative is wrong. There are real open questions. We still don't fully understand the social organization behind some megalithic sites. We have undeciphered scripts whose languages and contents remain unknown. We argue about how fast certain technologies spread and whether some bursts of innovation represent independent invention or borrowed knowledge from neighbours we haven't yet identified. There is also space within known science to consider earlier experiments in complexity. Coastal cultures drowned by post-glacial sea level rise. Riverine networks whose traces are now buried under meters of sediment. Dense trade systems that left only the thinnest material echoes. Being honest about those unknowns is part of doing good science. But there's a difference between saying, "We don't know yet," and saying, therefore, Atlantis. A balanced way to approach all this is to hold two attitudes at once: curiosity and methodological skepticism. Curiosity lets you ask without embarrassment, could there have been more? Could some chapters of human, or even pre-human, technological history have been largely erased by the Earth's own processes? Skepticism makes sure that, for any concrete claim you ask, where did this come from? What's the context? Can the dating be checked and rechecked by people who don't already believe or disbelieve the story? Does this fit or clash with everything else we know about geology, climate, biology, and the timeline of hominin evolution? When you apply those questions carefully, many famous theories shrink. Atlantis retreats back into the realm of allegory and later myth-making, with perhaps a dim echo of real Bronze Age disasters behind it. Ancient batteries become ritual objects with speculative functions. Spaceships carved on temple walls turn out to be layered symbols or damaged reliefs. Yet the big, quiet possibility that complex societies might rise and fall in ways that are hard to detect after hundreds of thousands or millions of years remains. It doesn't need crystal skulls or laser-cut stone to be interesting. It just needs the Earth's own machinery of erosion, burial, and recycling, working slowly on whatever fragile layer of technology happened to be left on the surface. If such a civilization had existed, and if any durable fingerprints of it survived, what would they actually look like? Not legends or lone artifacts, but patterns robust enough to stand up to all our tests. That's where we turn next. If we really want to know whether we're the first technological species to touch this planet, we have to ask a very unromantic question. What exactly would count as proof? Not a single statue. Not a weird artifact in a museum case. Not a myth that sounds a bit like a flood story somewhere else. What kind of evidence would force even the most skeptical geologist to say, okay, something non-natural happened here, and it was big? One place to start is with signals that don't care about pottery styles or ruined cities. Signals that spread through air, water, and rock. Signals that, once created, are very hard to erase. Chemistry is one of those. Right now, our own civilization is laying down a global chemical signature that future beings could detect long after our buildings have turned to dust. Think about synthetic compounds, plastics, PCBs, PFAS, pesticide residues, molecules that almost never occur in nature or only in vanishingly small amounts, suddenly appearing everywhere from polar ice to deep-sea mud. Even when the original material breaks down, its fragments and byproducts linger. Microplastics work their way into sediments. Chlorinated compounds bind to organic matter and get buried. Fluorinated chemicals resist breakdown for tens of thousands, even hundreds of thousands of years. Then there are isotopes. We enrich some elements, like uranium, in ways that shift their isotope ratios. We burn fossil fuels in volumes that alter the balance of carbon isotopes in the atmosphere and oceans. We create radionuclides in reactors and weapons tests that simply didn't exist on Earth before. Geologists call this kind of pattern an anomaly, a consistent worldwide blip in the usual ratios. If an earlier technological species had done large-scale industry, burned vast amounts of carbon, mined and refined particular metals, released exotic compounds, you'd expect to see some echo of that in the stratigraphic record. A thin layer in the rocks where certain isotopes suddenly spike. A strange mix of trace metals and synthetic-looking molecules that doesn't match any known volcanic or biological event. You can erase buildings, you can bulldoze cities, but it's very hard to fake a global chemical event. Another class of clues people talk about are technofossils. This sounds like science fiction, but it's a real term some researchers use to describe physical remnants of technology that might survive as fossils the way shells and bones do. Most of what we make is fragile on geological timescales. Wood rots, iron rusts, concrete fractures and returns to sand and lime. Even glass eventually weathers. But some things are surprisingly durable if they manage to end up in the right conditions. Ceramics can last for millions of years. Fired clay, porcelain, high-tech insulators, these are basically artificial rocks. They can be broken, but not easily erased. Certain alloys and composites, especially if they're buried in anoxic environments with very little oxygen, can persist as weird metallic nodules. Even the patterns we impose on the landscape can become technofossils. Deep, systematic mining leaves scars that go down hundreds of meters. Tunnels, adits, shaft systems. Large-scale quarrying cuts geometric cliffs into hillsides. If another species had industrially mined copper, rare earth elements, or iron billions of tons at a time, we might expect to find zones where the natural ore bodies are missing, or strangely reshaped long before humans ever started digging. That's an odd thought, looking for the absence of rock, for deposits that should be there given local geology but aren't. Compare that to the fragile things we often associate with advanced culture. Libraries, paintings, urban layouts. Those are the first to go. The technofossils are the last. If we wanted to search for those last traces, where should we look? The easiest place to build cities is not the best place to preserve them. Floodplains, river deltas, fertile coastal strips, the very locations that attract humans, are also places where erosion, floods and sea level changes constantly rewrite the surface. So people who think about long-lost civilizations often point to a few special environments. Continental shelves, the shallow seafloor ringing the continents. During ice ages, when sea level drops by 100 meters or more, these shelves become coastal plains. Perfect territory for settlement. When the ice melts, the water rises back over them, burying whatever was there under layers of sediment. Stable cratons, the old thick cores of continents, where the crust has been relatively quiet for hundreds of millions of years. No major subduction, less folding and overturning. If anything on land has a chance of surviving deep time, it's there. Anoxic basins, parts of lakes and seas where the bottom waters lack oxygen. In those dark, still sediments, organic matter doesn't decay as quickly. Fine layers build up like pages in a book, preserving delicate chemical signals and even soft tissues for astonishing lengths of time. Caves and deep karst systems, natural vaults that can protect artifacts from sun, wind, and surface weathering. Bones, wooden tools, pigments, even textiles sometimes linger in caves for tens of thousands of years if conditions are dry and stable enough. Over longer spans, the cave itself might collapse or be filled, but within certain windows they act like time capsules. The problem is, we've barely sampled most of these spaces in a systematic way. We know the land surface best, especially places that are convenient for modern settlement and agriculture. But the continental shelves, the deep interiors of old cratons, the submerged basins with anoxic bottoms, those are still mostly dots on a big fuzzy map. That's starting to change. New tools are letting us read the planet's surface and subsurface in ways that would have been pure fantasy a century ago. LIDAR, laser scanning from aircraft, can peel back forests and vegetation to reveal buried structures and landscape modifications. It has already rewritten our understanding of several known ancient civilizations, revealing networks of roads, terraces, and urban grids hidden beneath jungle canopies. Satellite sensing goes further. Radar that can penetrate dry sand and some types of soil. Multispectral imaging that can pick up subtle changes in vegetation, hinting at buried walls or foundations. Gravimetric and magnetic surveys that outline hidden voids and dense structures underground. Underwater, multi-beam sonar and high-resolution seabed mapping are gradually turning blank blue spaces on our maps into detailed topography. Sub-bottom profilers can see into the sediments beneath the seafloor, tracing old river channels and floodplains now drowned. Deep drilling programs bring up cores from ocean basins and ancient lakes, giving mile-by-mile chemical histories of Earth's atmosphere, oceans, and life. If there were a sudden, global industrial pulse in the distant past, this is where you'd expect to see its shadow. In the middle of all this, a quick reminder, since we're wandering deep into speculative territory together. If you enjoy drifting off to these long stories about deep time, the Channels book is available at sleepytimehistory.com, and there's a discount running this week. It gathers these kinds of slow, strange journeys into one place, if you ever want them in print beside your bed. When you put all the lines of evidence together, the chemistry, the technofossils, the special environments, the new tools, you get a kind of checklist. If an earlier advanced society had existed at anything like our scale, we might expect a global or near-global chemical anomaly not easily explained by volcanism or natural climate swings. Unusual concentrations or absences of certain ores, matching patterns of large-scale mining and refining, persistent artificial materials, ceramics, odd alloys, composite fragments, trapped in long-lived sediments or cave systems, landscape-scale modifications, canal systems, geometric terracing, rectilinear cuts, encoded not just in surface topography, but in subsurface structure. So far, when geologists and archaeologists scan the record, they see many dramatic events. Asteroid impacts, massive volcanic eruptions, abrupt climate flips, species radiations and extinctions. They see the rise of our own industrial signal in the very latest layers. But they do not see a clear, earlier industrial spike, with all those hallmarks stacked together. That doesn't prove that nothing complex ever rose and fell before us. Erasure is real. Plate tectonics, erosion, and sea level change are relentless editors. A small, short-lived technological culture, confined to limited regions, could, in principle, be mostly swallowed. What we can say, cautiously, is this. The deeper we look, and the more sensitively we measure, the fewer places there are for a truly global high-tech civilization to hide. The Earth is an excellent shredder, but it is not perfect. It keeps certain kinds of fingerprints even when it throws the rest of the body away, and those are the fingerprints we've been learning to read. So where does that leave us, here at the quiet end of the story? We've spent this whole journey walking through the ways the past can vanish. Geology, folding and grinding the crust, carrying whole continents down into the mantle and bringing them back up as something else. Water carving and smoothing, rivers eating their own banks, floodplains erasing and rewriting their surfaces, coastlines marching back and forth with every rise and fall of sea level. Climate drifting slowly and then lurching suddenly, turning forests to deserts, grasslands to ice sheets, drowning some landscapes under lakes while exposing others to fierce winds and frost. Catastrophes dropping in like punctuation marks. Super eruptions, mega tsunamis, impact events that for a little while rearrange everything. And above all, humans themselves, not just as builders, but as scavengers and recyclers, melting down old metals, knocking down worn-out structures to make foundations for new ones, burning what previous generations left behind for fuel or raw material. Each of these forces is its own kind of eraser. Together, over millions of years, they are ruthless. So, when people ask, could there have been someone before us? We're caught between two realities. On one side, the erasers are powerful. It is genuinely hard to preserve delicate traces across deep time. A small, localized technological culture, living along coasts that are now drowned, building mostly out of perishable materials, could leave very little after 1,000,000 years of storms and shifting crust. On the other side, the planet is not a blank slate. It keeps ledgers in stone and mud and ice, and we've learned to read them with surprising skill. What seems unlikely, based on what we've seen so far, is a truly global energy-intensive civilization at anything like our current scale, far back in deep time. The kind of world that lights up the whole atmosphere with strange chemicals, tears through ore deposits on multiple continents, and transforms ecosystems everywhere at once. If that had happened hundreds of millions of years ago, we'd expect something. A chemical echo, a mining scar, a technofossil where none should be. Some consistent global oddity that geologists keep tripping over and can't tie to known natural events. And so far the rocks are silent on that point, but between almost certainly not and definitely yes, there is a broad hazy space of maybe. Maybe there were regional cultures with toolkits we haven't fully recognized. Maybe there were brief experiments with complexity that rose and fell long before written memory, leaving behind only tiny, ambiguous anomalies in a few sediments we haven't drilled yet. Maybe some of the puzzles at the edges of our data, the odd structures on old seafloors, the unexplained gaps in certain mineral deposits, will someday turn out to be more than accidents of geology. We don't know, and it's important to be comfortable with that not knowing, because the mystery isn't just whether we had predecessors. The deeper mystery is that we can look back at all, that a thin film of living things on a cooling planet learned to ask questions about eras that ended before our own lineage even existed. That we can sit here half asleep in the dark and follow threads from isotope ratios in ancient mud to speculative stories about forgotten cities on drowned plains. In that sense, we are already part of the record. Our plastics and power plants, our tunnels and satellites, our words and worries, all of it is becoming part of the strata that some distant mind, human or not, might read someday. They may never know our myths. They almost certainly won't know our names. But they might see the sharp, bright line where we appeared, the sudden chemical flare, the strange technofossils, the rearranged rivers and forests and coasts, and they might wonder, in their own language, whether we were the first, whether something else came before us, erased in turn. If this kind of slow, speculative drifting through prehistory helps you sleep, there's more waiting for you. The channel's book about prehistoric secrets gathers these stories of deep time, lost worlds, and quiet mysteries into one place. If you ever want them on the nightstand instead of the screen. For now, if you'd like to help these strange little journeys continue, you can gently tap like and subscribe so you don't miss whatever world we wander into next. If you're still awake enough to type, let me know in the comments where you're listening from tonight. A city apartment, a farmhouse, a dorm room, a ship at sea. It's always a quiet kind of wonder, seeing all the places this one small story reaches. Wherever you are, and whatever layers of time lie beneath your feet, thanks for drifting through them for a while.